Alright, in this video I'm going to be talking about gradient descent. Gradient descent is an optimization algorithm and it helps us find the minimum of a differentiable function. It's especially useful in machine learning to minimize the loss function of a model. And the loss function measures the difference between the actual values and the ones predicted by the model. So to be as accurate as possible, we want to minimize the loss. So we want our model's predictions to be as close to reality as possible. A common example of a loss function, particularly for regression tasks, is the mean squared error, or MSE. For each prediction, we'll calculate the difference between what our model predicted and the actual value, square that difference, and then average it over all our data points. By squaring the difference, we can make sure that all errors contribute positively to the loss, so we don't have like a negative value being added on, and that larger errors are penalized more heavily because the larger the error, the larger the squared value, whereas smaller values have smaller square values. The formula for this is as follows right here, where n is the number of data points, yi is the actual value for the ith data point, and then yi is the predicted value for the ith data point. So when you are trying to minimize the loss function, you're going to try to find, of course, the minimum of the function. So in this case, you can see on the graph, the minimum would be at the bottom of this curve, right? So we want to find a way to approach that. If we start at a certain point, like you can see this blue dot here, this is where we set our weight or our parameter to some arbitrary value, and we start trying to reach the bottom. A common analogy for how we do this would be being on a mountain and trying to find the fastest way down, but everything around you is covered in fog. So you have to use the most local information that you have, which would be the steepest descent and the proximity that you're able to see. You'll take another step after you do this and repeat the process. And then hopefully, as you do this over and over again, you eventually reach the bottom of the mountain, the lowest point. So we want to imagine that we have some loss function that only depends on one parameter of our model, which is a single weight, as I have on the graph here. On the graph that I have here, the horizontal axis represents the value of that parameter, and then the vertical axis represents the calculated loss, or the value that we get from the mean squared error for that parameter. Now, this is what makes gradient descent iterative, because we start at an arbitrary point with our model's initial parameters, and then we find the steepest slope with those parameters by calculating the gradient. And this is a technique from multivariable calculus, and it points in the direction of steepest descent. Since we just have a 2D graph here, we can just take the derivative to find the rate of change and see the fastest rate of decreasing change, which is always just going to be opposite of the greatest increase, right? So it's basically just calculating the slope of our tangent line to our loss curve at our current parameter value. So since the gradient tells you the steepest descent, we take a step in the opposite direction, and then the size of the steps that we make, as I have with these red arrows here, will be the learning rate, a parameter that can be controlled. The learning rate is important because if the learning rate is too small, it'll take forever to reach the bottom. If it's too big, you might even miss the bottom entirely. You'll repeat this process iteratively until the lowest point has been found, or in other words, until the loss function stops decreasing at a significant rate, or the changes in our parameters become very small. And then at this point, we've hopefully found the optimal set of parameters for our model. Visualizing with one parameter is pretty easy, but most machine learning models have many parameters. In those cases, the mountain becomes a high-dimensional surface that's impossible to actually draw, but the core principle remains the same. You can use gradient descent to find the direction of steepest descent, even in a complex parameter space, to reach the minimum loss. So that's an overview of gradient descent. Hopefully it was helpful, and thank you for watching.